Shooter's Touch, implementing energy return elements in upper limb prosthetics. There are roughly 2 million people living in the United States with limb loss. Research and innovation have primarily focused on prosthetics for the legs and feet. The sport-specific prosthetic for the lower extremities was very successful. For example, Cheetah leg. It uses a carbon fiber spring, which stores the energy from the runner during the drive phase and releases at toe-off to generate propulsion. However, existing upper extremity prosthetics are limited in functionality and typically designed for day-to-day grasping tasks. In this paper, we draw inspiration from the energy storage and release design of Cheetah leg and implement similar function with two novel computational springs in upper extremity sports prosthetics. First, we iteratively designed two separate mechanisms, a coil spring and a cantilever spring, and added a force sensing feature to the mechanisms using multi-material 3D printing. With this novel spring structure, we can store the energy applied to the spring and release it later, while quantifying its amount. Second, we researched the biomechanic principles of basketball shooting and incorporated novel spring elements by mimicking wrist flexion and finger motion. Lastly, we developed a real-time monitoring system to support customization and modification of the design, including energy return. For more technical results and research implications, please refer to the paper submitted.